Well, how's it going, guys? We did it. It's the last one, and we're going to end on one that is probably not as interesting as far as things exploding or cool lighting or shadows or that kind of stuff. But when we get finished, I hear that there'll be beer outside, so yeah. So let's talk a little bit. We're talking about continuous integration, and I feel like this is something that has taken hold in the general software development world, but not as much into game development yet. So maybe we'll look at this as a way that you can start applying these practices to your team, and maybe not do everything at once, because that would be pretty hard to do. But let's get into it. So a little bit about me. I've worked in C# for a long time. A long time worked on just general app development. And in recent years, this slide's a little out of date, but we've done games in Unity and started working on our own stuff. But for a long time, we did software development. Just people hired us to build an app or build a website or that kind of stuff. And so that's where I've gotten a lot of these practices and applied it to game development. I work for a company called HitSense, and we're based in Kentucky. Started in 1999 with two twin brothers in high school, and it kind of transitioned from just being a web development company to doing desktop apps, and then mobile development, and then here in the recent years, we've really been doing a lot more game development. So here's a few apps we've done. In 2012, we released a game called Draw Stickman Epic, and it was built with C# and Monogame. And that was our first game that we had built and released just as a company. You know, it was a totally new direction, something we hadn't done before. And then in the past year, we released a sequel to that game, which is actually built with Unity. And it's we moved to Unity not because there was a lack in Monogame, but it had a lot of better tools for non-technical people. You know, the Unity editor, you can do some great things and not really have to be a technical person to use that. And to contrast that, we've done an app for the actor Tom Hanks called the Hanks Rider, and that app is also built in C#, but we use Xamarin to build that app because it's just a native app. It's basically something to be obnoxious in coffee shops. It turns your iPad into a typewriter with clicking sounds and stuff like that. So, but anyway, so let's get into it. What is continuous integration? So, if you look on Wikipedia, there's a big long thing that you probably won't understand. It uses a lot of big words, but it is actually a pretty simple concept. So, at the very basic level, you keep all your code in source control. So that's step one. And your code is built automatically. So when someone checks in a commit, they change something, something goes off and builds your project. And then at some time after that, something checks that your code is right, that it's okay. And this is the part where maybe you don't do everything you need to, but you got to start somewhere. So. And the goal is basically to catch bugs early. So if you think about the progression of when you can catch a bug, let's say you're coding something, you find it right there, that's the best spot. You could have the build fail, like you have a code error, or it doesn't compile. You could have a test fail. You could have a QA tester find the bug. You could have your boss find the bug, download a beta, or it could happen to all your users. So there's the progressing, each step gets worse and worse, and the goal of continuous integration is to catch the bugs as early as possible. So let's talk about the dream. So the dream, this is what, if a big shop, they built the game perfect, and this might be the process that they go with here. So they'll put everything they work in into some kind of bug tracker or task tracker, and then they'll commit their changes to source control, and they'll have some kind of software that actually builds their app or their game. And this could be TeamCity or Unity Cloud Build, some kind of software like that. They'll have some number of tests that run as part of the build, and then they'll have builds automatically go to some kind of beta testing, some location where all their builds are held for people to download and install. And then finally, those builds will go off to the app stores. And this chart really should be a circle in that when you get to the app store side, you might have bugs come out of that, and then you start the whole process all over. But that's why I say this is the dream is, if your team is not doing these things, don't try to do all this at once. Try to take smaller steps to get your team more acclimated with how this works. That's just what I talked about. So let's talk about the first one. This one's probably pretty simple. This is not technically CI, but I think it is very beneficial and it really fits in with the whole mix. Most development teams have so much to do, so much going on that it's hard to manage everything that they need to do. And using some software really can help with this. So, for example, Jira is a good example, and GitHub also does this as well, but you can actually close a task with a commit. And that is actually pretty helpful because your QA team could put in a bug, and you could fix it, and then it gets closed with the commit, and the QA team can see that you did that. And then they see the build that came out as a result, and then they can test it and verify that everything is OK. So that's what that software helps with. And the other thing is managers actually can see what's going on with the project. Depends on the size of your team, that might be more important, might be the most important part. And even a one-man team working on a game by himself could benefit using something as simple as Trello as just organizing his ideas, a to-do list of everything he needs to do. And here's some good examples. I talked about Jira a little bit. That one's kind of the standard one, general software development people use. GitHub is also a great one. It's free if you have a GitHub account. Maybe you have to pay for some repositories, but the issue tracker comes with that as part of your subscription. And then Trello is just completely free. You might have to pay when you get an organization of some size, I think, with Trello. So here's what our Trello board our Jira board looks like. And you can see we got a lot of stuff going on. And I think one important thing to highlight is that we have artists working alongside programmers on this board. I think that's a key thing. And technical people and non-technical people may not want to talk to each other. And kind of having this view of what's going on makes you feel like you're more a part of the team and really working toward the same goal. So let's talk about the next one, source control. Hopefully you're using source control. It is 2015. Backing up your code in a zip file or maybe putting it on Dropbox, that's really, it makes me nauseous to think about it. But anyway, there's a lot of reasons to use source control, and I won't go through all these. But basically, it's not only does it back up your code, but you can see what happens to your code over time. You can go back and find something broken, say, oh, what did we do to break that? And if you have continuous integration set up, you can actually run a build on a past commit or do things like that. So it's just, I think if you're not doing anything in this talk, this is the first thing you should do. Is go ahead and set up source control and use it in some form. So basically, any source control system will work with Unity, maybe not some ancient one. But the first one you might go to look to if you've not done it before is to go ahead and try out Unity Asset Server. I think it's pretty simple, and it's right inside of Unity, and so it might make sense for your team because they've already got Unity to go ahead and try this out. There's also a subversion that's been out a long time, but it's also pretty simple. if your team has not used it before. There's a nice plugin for Windows called Tortoise SVN that is really, really simple to use. And then you've got some paid options out there. These also are built into Unity, but they're kind of expensive. Perforce and Plastic are both kind of in the same camp here. They do a lot of things. If you have a really large team who work in different parts of the world, it might make sense to use one of these. But if you're just a smaller team, it may not be something you need. And then so there's some other options. Mercurial and Git are both very similar. I prefer Git. We use Git and GitHub at HitSense, but Mercurial is just as good. And both of these, Git in particular, they have a nice desktop app called Git for Desktop, or GitHub for Desktop, I'm sorry, that's come out recently that I think non-technical people can really use it pretty easily. So let's talk about how to set up. What do you actually have to do in Unity differently to use source control? So one thing that's kind of key is that there's a lot of stuff Unity puts in your project folder that you don't need to commit. And that's why I use a website called getignore.io. You can type in all kinds of tags like Unity, Windows, Visual Studio, and it'll give you an ignore list that's just pre-populated, ready to go. You don't have to think about it. And it'll keep you from committing those weird files that'll mess things up. Another thing you want to do if you're using Git is there's a nice little editor setting that turns every Unity file into text mode. And so what that does is it prevents you from committing these files as binary, which doesn't work well when you go to Git. You can't see your changes. You can't, when you turn on this mode, you can actually see when you check a box in Unity and that it went from off to on, or you typed a text field in a setting. Another thing you'll need to do is to turn on visible meta files if you're using external source control like Git. This will make a file that sits beside every file in your project. And if you're using a Unity Asset Server, you don't have to worry about these. So that's a benefit. And then just an FYI, if you have a lot of huge files in your project, GitHub kind of has a limit on the largest file you can have in a repository. So you might want to look into hosting your own source control on your own server, or maybe looking at another provider there. And so Unity has a great guide on setting up all kinds of source control, every one you can think of. And this is actually on Unity Cloud Build's website. And you might go check that out if that's something you're looking into, how to do it for a particular kind of source control. All right, hopefully we can get through this. Let's talk about testing. So source control is a no-brainer. I feel like testing is probably the hardest thing to implement, with your team, because who has time for that? Who wants to stop working on the game to write a test to make sure the game works? You just want the game to work. You don't want to. Nobody has time to do that. But that's why I think there are some advantages here that you can get started writing tests, and once you get in the groove of doing that, maybe that can keep going. So why write tests at all? It lets you, if you have tests that check that your game is correct, you can change a lot of stuff at once and actually be kind of certain that you didn't break anything. And I think this is kind of important when you think about when you go back to your game and you have to optimize for performance, or you fix a bug. Oh, that was way down deep in some low-level thing. Does that break the game anywhere else? And so writing tests can really give you a good confidence level of getting that fear of breaking something out of the way. So the best way for writing tests with Unity, Unity has something on the asset store called Unity Test Tools, and these are free. Basically what this does is it gives you a test runner that is inside of Unity, and it also gives you a set of integration tests framework, which we can talk about the differences. So there's two types of tests. The unit tests are a very, very small level. They are in unit, which is pretty standard for C# and .NET. Basically, they run in the editor, and they're meant for very small units of logic or work. Maybe you have some stuff in your game that's doing math or running stats or leveling up a player or those kind of things. That's what a unit test is for. And so because those are very small and you can only run them on certain things, there's some drawbacks. Like you can't use coroutines. You can't really do anything that depends on the Unity engine running, so you can't make sure physics are colliding correctly with a couple objects or do things like that. And you can't run the tests on devices either. So that's what the integration tests are actually for. So what these are is you can think of it as a Unity scene with a big tree of objects that each object is a test. And what it can do is, like, for example, you throw a couple prefabs in your game in there, and you want to make sure that this enemy kills your player within 5 seconds. That would be a good example. And so what that would do is it would actually load up a scene, create those things, and make sure the right thing happens. And I think this is really the best place that you can get started with writing a test, is to, in a broad stroke, test a big chunk of your game with one test. And I think that is really the best way to get started and know if someone actually broke something. And so in an integration test, like I said, you can test any part of your game. The full Unity engine is running, and you can even run integration tests on mobile devices. If you're concerned that a certain thing is broken on iOS or Android or just one platform, this is a way you can test those things. So here's what just a unit test looks like. This is pretty simple. I think this came with Unity test tools as a sample. If you've ever seen a unit test before, this is what it looks like. You call some code, and you call assert, and you check that a value is true, or that kind of thing. So that's pretty straightforward. And you might think, it depends on how your game is built. You may not have your game architected in a way where it's easy to write unit tests. And so this might be something you look at for only very complicated parts of your game, or maybe parts of your game that you want to write tests before you throw it in the game to make sure that the code you're writing is working. And here's what an integration test looks like. It's kind of hard to see, but it's basically just a scene with a bunch of tests in it. And you can run them individually, and you can actually watch the scene view while the test is running to see what happens. And you can actually set up your assertions just inside the Unity editor. You can actually set up a lot of them without writing any code. You can say, after so many seconds, check that this thing is true, or check that this game object is gone, those kind of simple assertions. All right, so automated builds. We're almost there. I think this is another step if you have source control set up, especially with Unity Cloud Build. This is the next no-brainer step that you should probably look at for your team. Because who on your team really wants to start a build and then watch a progress bar for 15 minutes? Maybe there's a guy that you don't really want coding, and maybe that's his job, but it's really, you're just going to save a lot of time if you have some server somewhere that builds your game, and you don't have to build it on a developer machine. So the best option here, especially if you're getting started, is to use Unity Cloud Build. It's absolutely the easiest way to get started. If your code is in source control, it probably already works with Unity Cloud Build, because it basically just checks it out, and then some magic happens, and then a game pops out. You get an email. So you can build projects that are in Git, SVN, Mercurial, Perforce, and they're probably adding more all the time. I might have left one out. So if you're looking at this option, you might want to pick one of their supported source control systems. And they also support PC. Today they announced PC, Mac, Linux, You also can do iOS, Android, or the web player. So that's almost every platform that you would want your game to be deployed to. And you can also do things like, let's say you have 2 or 3 versions of your PC game. You have one that goes to Steam, you have one that's downloaded off your website or some other store. You can do that as well. So just because it says Android, that doesn't mean it's just Google Play. You could make an Amazon build for Kindle or that kind of thing. And so Unity Cloud Build, it's really cheap to get started. You can probably just go try it for free. And for the very largest team, it's only $100 per month. There are some options beyond that if you really have a large project and a lot of stuff going on. But I think for small teams, it's pretty affordable. It's probably going to cost you less than that $100 price. So what can Unity Cloud Build not do yet? So these are maybe some fringe things that might prevent you from using it, but they're here nonetheless. They don't have Windows Store, Windows Phone yet. You may not care. But all our games are on those stores. And that's a good thing for us to get some extra revenue there. So you also can't build non-Unity projects. It's kind of obvious. If you've got some server-side code, maybe some PHP side or some, who knows what, ASP.NET, you're not going to be able to build those on Unity Cloud Build. It's also focused on builds. So when you look at other software that is full CI software, they're a lot more focused on running tests. And so they'll have graphs and show you the history of a test, show you the commit of how long this test has been failing. You can definitely run tests on Unity Cloud Build, but it's just not focused on giving you all that data of what's happening with the tests. And so here's what Unity Cloud Build looks like. I think this is just a really old build of our game, but the numbers are out of sync. It's pretty simple. Basically, every commit, by default, every commit starts a build, and you'll get an email within probably 15 to 20 minutes, depending on how big your game is. And then there's just a link in the email to click and install it on your device. So let's talk about if you can't use Unity Cloud Build, or you have some reasons you want to go beyond that. Let's look at what that looks like and how you can set that up. One good reason you might want to do this is if you have spare machines lying around, you just want to use them, and you don't want to pay per month for the cloud version. Or your builds take a really long time. So you can definitely get a physical machine that's going to run faster than Unity Cloud Build just because in the cloud, everything's virtualized. So this might be something you look at. And if you need to build both Unity and non-Unity projects. And then another option, let's say your source code is on a private repository. It's not on the internet. It might be difficult to get that working in the cloud. So we're kind of running out of time. I'm going to speed through this a little bit. It is a little complicated, but we'll see how we get through it. Let's just talk about how Unity makes a build. So everything starts as Unity is started in command line mode, and it basically executes a static method on an editor script. And on iOS, an Xcode project pops out, and on Windows Store, a Visual Studio project. And some platforms like Android or PC, you basically just get the binary out, and those are the simple ones. But for some obvious reasons, some platforms are more complicated, and so that's why Unity spits out a project for you. And it's your job to build the exporter project, and a good idea is to completely build the whole thing with scripts and not try to write some documentation on steps. Step 1, do this. Step 2. Because it's probably going to save you a lot of time and heartache to just go ahead and automate it. And then after this, you can use this attribute called post-processor build, and you could go monkey with that Xcode project or Visual Studio or whatever. And that's how you can fully automate the process. So some choices if you want to automate everything yourself, one way to go is some software called Jenkins. It's built with Java, and it runs on Unix or Mac OS or Windows. And that's been around a long time. It would work great with Unity. The one we use at HitSense is called TeamCity. It costs money, but I think it's kind of worth it. It's very focused on .NET and C#, so a lot of things are built in, like analyzing in-unit test reports and things that you'll want to always do on every build. And then there's some other options out there that maybe aren't the best, because as part of your build, you'd have to download and install Unity. And so the Visual Studio Online is kind of in this camp too. I don't think these are really the way to go unless that extra time and doing that is not a big deal for you. So why script your build process? So you want to make it as easy as possible for someone to make a build, and then you also want your build to be documented over time in your source control. So you're trying to avoid any manual steps in your build to save as much time as possible with your team there. And having a build script will kind of get you to automate more and more stuff down the road. So we're going to skip through a little of this and kind of just show an example. So here's an example of starting Unity at the command line to build something. And here I've got a editor script called build script with a static method named Android. And that's going to be where the code is that actually runs the build. And there's great documentation on this on Unity's site. Here's what that script looks like. Pretty simple. I think this nice link statement makes this even simpler. Basically, you give it a list of scenes and a path to an APK, and that's all you have to do. And so here's an example of this is a fake script. Fake is an F# build scripting language. This might be something you look into to actually fire up Unity, and then you can actually build things after Unity's done. And this is, if you're really getting advanced and you're wanting to do a lot of stuff in your builds, this might be the way to go. But you could also do this just inside your Unity editor script, and that might be the route you want to go. So this is what our TeamCity looks like. We've got a lot of apps in here. Some of these are games, some are apps. We've got one failing. I might check that out later. But you can see where you've got a nice instant progress report of how all of your projects are going. And it's just nice to track everything here. So I kind of had to rush through that a little bit. I do have an example up on my GitHub of just a simple project that has a fake script set up and can build for iOS or Android. And you might go check that out if this is something that you're wanting to look into. I also have a few blog posts you could check out. I've got links on there too. So I think we've got like a minute left. Maybe we can do a question or two. We're going to skip past. We'll just leave it here.
Hey, how's it going? Thanks. I was wondering if you ever run across problems using Git with Unity with scene merging. We have a big problem with that, so much so the fact that we have a physical token. It's like only one person can do scene changes at the same time.
Well, I think two things help with that. The force text mode, if you guys have that on.
Yeah.
Unity also has a tool that I don't know how stable it is that lets you merge YAML files.
Is it the smart merge thing?
Yeah. And I don't have a link on here, but you can find it on their docs site.
Yeah, I just heard about that. I don't know anything about it, but.
Well, yeah, it's pretty recent, I'm pretty sure, and so it might be something you want to look into. A lot of times what we do is just kind of pick the person who we like their commit better. We'll get rid of his and pick theirs, you know. That's kind of the thing you have to do.
Okay, cool. Thanks.
I think that's it. Thanks, guys.